In this video, we're going to look at special types of reactions called oxidation-reduction reactions. Oxidation reduction is one of the most important and common types of chemical reactions. In fact, some of the types that we looked at, such as single replacement, decomposition, and combination reactions, are sometimes oxidation-reduction reactions. Oxidation is the loss of electrons, and reduction is the gain of electrons. An oxidation-reduction reaction is often called a redox reaction, and it involves the transfer of electrons from one species to another. So the learning goal here is to define the terms oxidation and reduction and identify the reactants that are oxidized and reduced. So, oxidation-reduction reactions. They provide us energy from food, they provide electrical energy in batteries, and it occurs when iron rusts. So if you look here, we have a combination reaction. We have two simple molecules coming together to form one molecule. But this type of combination reaction is an oxidation reduction. So in an oxidation reduction reaction, as I said previously, electrons are transferred from one substance to another. Oxidation is the loss of electrons. Reduction is the gaining of electrons. So if you look at A and B, A is going to lose an electron and transfer it to B. So you can see A is oxidized and B is reduced. The green patina that is on the Statue of Liberty is due to the oxidation of copper metal as it forms a green solid, copper oxide. So here, our first equation, we have copper solid, and when copper solid loses electrons, it becomes oxidized. Here you have oxygen gas gaining 4 electrons to form an ion, O2-. And then we get our solid copper oxide. And again, if you remember from our naming, it would be copper 2 oxide. Copper is a transition metal that can have different oxidation states. All right, so let's look here where we have zinc metal transferring electrons to copper ions. So in this solution, you have copper sulfate. We're going to put in a strip of zinc metal. And then you can see this reddish color deposited on the copper surface. What's happening is that copper is gaining electrons, copper 2+ is gaining electrons from the zinc metal. So these copper ions, in the presence of this zinc metal, you're going to have a transfer of electrons. So that the zinc is going to lose 2 electrons, and copper is going to pick up those 2 electrons to form neutral copper that you see copper depositing on that metal strip. So let's identify these following reactions as oxidation or reduction. Pause your video. In the first reaction, we have tin solid, and tin is losing 4 electrons, so that would be an oxidation. In B, we have iron 3+ plus 1 electron, forming iron 2+. So it is gaining an electron, so this would be a reduction. All right, in this last reaction, we have chlorine gas gaining 2 electrons, so that would also be a reduction. What I want you to realize is that oxidation-reduction reactions occur as a pair. You need to have them occur as a pair because whatever is lost must be gained. What we're seeing here are half reactions. So for every oxidation that's occurring, a reduction is occurring as well. So here are the answers that we previously listed. In light-sensitive sunglasses, UV light initiates an oxidation-reduction reaction. So these are those sunglasses that change color. So here we have silver and chlorine ions. You expose them to UV light and you have silver metal and chlorine gas. So which reactant is oxidized, which one loses electrons, and which reactant is reduced, which gains electrons? You should see that silver is going from +1 to a charge of 0. So silver is gaining electrons. So silver is reduced. Chlorine is going from 1- to 0. So chlorine is losing electrons. So chlorine is oxidized. Cl- is oxidized. All right, so again, Cl- is oxidized. It loses 2 electrons, whereas silver ions are reduced to form neutral silver. What I want you to realize, again, so I said previously that these were half reactions. So what you can see is that these electrons actually cross out to give you the balanced equation that was listed above. So again, for any type of oxidation, there has to be a paired reduction. We observe oxidation-reduction reactions in biological systems. This is how we get energy. So what's depicted here is the coenzyme FAD, flavin adenine dinucleotide. As we are oxidizing glucose as fuel, glucose becomes oxidized and loses electrons. It's going to lose electrons in the form of hydrogen. These electrons are going to be picked up by these coenzymes, and these coenzymes become reduced. So you can see this FAD gains 2 electrons and forms FADH2. This coenzyme is in its reduced form. It goes on to the electron transport chain, where it will transfer its electrons down a gradient to oxygen, the final electron acceptor in respiration. So similar to what I described previously, the transfer of electrons biologically typically happens in the form of hydrogen atoms. And this is showing you how the body metabolizes methyl alcohol, a poisonous substance, by the following reactions. The methyl alcohol is oxidized to formaldehyde, and it loses electrons in the form of hydrogen atoms. Those electrons will be accepted by some type of electron carrier, such as FAD, and form FADH2. We'll learn about additional electron carriers, such as NAD+, where those electrons can be transferred and form NADH. That formaldehyde is further oxidized to form formic acid, and the formic acid is oxidized finally to carbon dioxide. These intermediate products, formaldehyde and formic acid, are toxic and cause headaches and possible death because they interfere with key reactions in cells. So characteristics of oxidation-reduction reactions. So they're always going to occur in a pair. Oxidation involves a loss of electrons. You can also observe oxidation as the addition of oxygen and the loss of hydrogen atoms. We'll see this when we look at organic reactions. For a reduction, this involves the gaining of electrons. Again, from the organic perspective, we'll see this as the loss of oxygen and as a gain of hydrogen. So, we should be able to identify what is oxidized and what is reduced when we have a chemical reaction.